what a month it's been since that historic Christmas Day morning. Let me just do a little sort of background refresh here. Astronomers have been trying to unlock the secrets of our universe for literally centuries and trying to answer questions like, how did the universe form? Where did we come from? Are we alone in the universe? And we have developed some incredible equipment and technology to try to answer these questions. And we have come so far. Just think about how far we've come since Galileo pointed his little telescope at the stars, and he was able to look at the craters on the moon. He'd look at the sun. And remember, do not point your telescope at the sun unless you have proper filters or use the projection method. But he noticed that there were blotches or sunspots on the sun. He even looked at the planets. Venus, he could see the different phases. He looked at Jupiter and could see the tiny moons, the 4 Galilean satellites named in his honor. So there was so much. And look how much we've come over 400 years. What we now see. We now have huge observatories, and we have one of the largest observatories in Canada, just south of Calgary, the Rothney Astrophysical Observatory, that we've had public star nights pre-COVID, and hopefully we can get back there again and enjoy those Milky Way nights. But astronomers have long understood that if we can launch a telescope above the distorting atmosphere of the Earth, we could see so much more. And the Hubble Space Telescope, launched way back in April of 1990, has literally rewritten the astronomy textbooks. I'm sure you've seen some of these iconic Hubble images, like the one on the left, the pillars of creation in the Eagle Nebula, or the image on the right, where the Hubble Space Telescope was pointed at what appeared to be a rather blank part of the sky. And this is called the extreme deep field, where over many years of accumulating images, they have produced this deep field image that shows over 5,000 galaxies. So what we thought was once a bare part of the sky or blank part of the sky is full of galaxies. So Hubble is over 30 years old, and it's small. It's got about a 2.6 meter primary mirror, and it's time to launch its successor called the James Webb Space Telescope with 18 segmented mirrors, hexagonal mirrors, that would produce about a 6.5 meter telescope. And this was the launch on Christmas Day.
6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
That was the best Christmas present I think astronomers around the world could ever have wished for. And about 27 minutes later, these stunning images of the telescope being released by its booster on its way to the Lagrangian point number 2, a very gravitationally stable point that's orbiting the sun. And I'll explain that a little more here in a moment. So over the last, what has Webb been doing? Well, it's been unfolding itself. In order to fit this giant telescope inside the nose cone of the Ariane rocket, it has to be folded up in many, it's like think of an origami puzzle almost in reverse though. So it was all folded up and now it's unfolding in space. And there were so many things that could have gone wrong. And, it's been an absolutely perfect so far unfolding of this, incredible machine. And here we see the sunshades being unfolded. This has been accelerated, of course. We're going through many days here in just a few seconds or minutes. But there's the sun shield being unfolded. And I'll explain why it needs this sun shield, because this is not a normal telescope. It's not like us using our optical telescopes or even like Hubble. Hubble had a visible electromagnetic range for viewing the sky. But James Webb is an infrared telescope. So right now it's on its way to what's called L2. There are 5 stable places in the orbit around the sun with the Earth. So this is L2. It's about 1.5 million kilometers away. And the James Webb Space Telescope will have this sun shield blocking the light from the sun, the earth, and the moon, and plus the heat energy as well, to keep this telescope very cold. And when I mean cold, I mean really cold. And that's because the electromagnetic spectrum here, you can see the tiny visible spectrum that we see, but we're going to be looking at the infrared spectrum with the James Webb Space Telescope. And infrared is basically heat. So if we're, getting warmed up by the sun or any heat reflected from the earth or the moon, this would obviously contaminate or ruin the images that James Webb is trying to capture with its sensitive sensors. So it wants to be kept in the shade and very cold all the time. And this was what I feared the most. I'll be honest with you. I was watching the NASA broadcast live as this very complex unfolding of 5 layers of very thin plastic coated with some aluminum on the backside to reflect the heat of the sun. And each one is separated by a little gap to prevent the heat from being transferred over. So it's like a vacuum of space as an insulator. So the sunshades to keep James Webb very cold, and we're talking below minus 200 degrees. In fact, they're aiming for at least 223 degrees below 0 Celsius. Now, Canada is a partner in this exciting mission, as well as Europe. So Canada has provided the fine guidance sensor that you see here, and also an instrument called NIRIS, the Near Infrared Imaging Slitless Spectrometer. And here we see it being unboxed and ready for placement onto this big telescope. So where is Webb right now? Webb is almost at the L2 point. It is 96% or more at its planned orbit, and it's already below 200 degrees Celsius on the cold side is what they're aiming for. So they want to be even a little colder than that. The Canadian instrument, I might add, will not be turned on for at least 50 days after launch, so that it is chilled down again to a very cold temperature. Also, what is Webb doing? Well, the mirrors were locked for launch. They're all being unlocked right now. They're being little tiny motors are being used to adjust them and get ready for its first light image. So this is called a wavefront process, and it's going to take at least 3 months to get all the mirrors aligned perfectly. And what's next coming up very recently, as was mentioned, there's going to be the firing of thrusters this Monday at around 12 noon Mountain Standard Time. And this burn will place James Webb into its operational orbit 1.5 million kilometers away. That's in a gravitationally stable part of the orbit in the solar system between the Earth and the sun. And it's just going to be like in this halo orbit for hopefully many, many years. So the historic first image, when can we expect it? And I'm putting images in brackets because there was some discussion that it might not just be one image, there might be a series of images, but the first image we can expect probably in about 5 months' time from now, after everything is calibrated and collimated and all the sensors have been calibrated. So we'll see. I just cannot wait to see those images. And the Webb science, trying to look for the first light after the Big Bang, first generation stars and galaxies that are, that we haven't, they're larger and maybe more complex than models even predict, looking for other planets around other stars. We call them exoplanets, and not just looking for these planets, but looking at their atmospheres, what their composition is. Can we see what those atmosphere, what if we found water vapor or even oxygen? It'd be very exciting. So this is something to look forward to in the months and years ahead. And that'll end my brief James Webb Space Telescope update. And now we're going to go off to Venus, and I'm very excited to hear Dr. Grinspoon's presentation. Take it away, back to you, Simon.